and use other people's software. And then we moved into what we would now call social media, the social use of the web. And it's very much become a web of people. So people being connected back and forth and sharing and thinking about our universe of people in a different way. And we're just on the cusp of really moving into a total web of, and it's usually called Internet of the Webs, but since I was talking about the evolution of the web, I thought I would just call it the web of things. And so this is about all of that, every single little thing that we own that has a chip in it or has an RFID tag. What happens when these things are all connected? So let me just start right out here. So we tend to talk about the internet as though it started in 1989 with Tim Berners-Lee and the CERN Observatory in Switzerland introducing the notion of HTML files. And then soon after that, in that same sort of time period, we had search engines for FTP files. So those were just simply files moving back and forth. And then we moved into the notion of an interface, so people could actually search. They didn't have to know what was at the other end. They could actually start to go, and we had this notion of a web or a universal repository of files that would move around. And I know none of you are old enough to have ever used Gobo or Veronica, but they were sort of early Googles, if you like. They were early ways of trying to let people get at data in files that they didn't know existed before they started the search. So at that time, you know, people were talking about thousands or 100,000 servers and you know, 200 or 300,000 documents. And so you can see it sort of started small. In the 1970s, there were enough computer networks around that people were, especially researchers and scientists, were moving files back and forth with their friends and with computers around the world. And they had this notion of file transfer protocols between servers or between computers, essentially. And they were just that. The file, I had a file over here with data, and it would move from my computer to your computer. So Nazreen would receive a file, she would know whether it was a binary file or a numeric file, and she would work with it at her end. And that worked fine, you know. We all, if you knew what was there, you could go and request it and it would come. And you could move the data both ways, so you could upload and you could download. And then these systems that I mentioned before, so Archie, which was actually a search engine for FTP files, started in 1990, and it was extremely popular because it meant that you didn't have to contact your friend and say, what's the name of that file? Could you send it to me? You say, I'll just go and I'll look to see what my friend has on her site. So this notion of kind of directories of files that were available. So individuals started to thinking about open files, files I wanted other people to come and see and perhaps share, and the things I didn't want to share. And so that, if you think about that, that's not much different than having your public HTML directory. Those, you put things there because you're willing to have other computers and people go and look. And I'll show you a couple of these. So that actually kind of lasted for most of the 90s, and Gopher was the most popular. So as we moved into the actual web, we started a new protocol, which would be HTTP, which I'll also talk about in a second. And that was actually a hierarchical menu. So the notion of more like a library catalog. You're interested in biology, or you're interested in mollusks or lions or bugs. And then we have, these are the files that are there. So trying to get a universal categorization. And Veronica in 1992 was really the first universal database, so that you actually went there and you searched. So you weren't going all over the place. You went there and you searched there, but again using menus. So you can kind of see how the way that we started to think about these files that are available has gone from just personal into the notion of could you describe it like a library, so an old model, and then could I just search everything? And so let's just take a look at a couple of these as we move forward. So this is from ERIC is a big educational information retrieval system in the States. And this is a very old slide, probably 1990. But you can see where it actually it looks like a library, right? So it's all about educational. So are you interested in bibliographies, professional organizations? Then you click on there and it will actually say, well, what kind of bibliographies are you interested in? And then at some level it would list all the files that were available. You could select it and it would come to you. So here was Archie, the first one that actually starting to look Google-like. So you just put in a term. Here I put in Dalhousie. I had all these kind of interesting options, but you can hardly imagine Google asking you, did you want to do a Polish web index or a regular expression? So only the computer science geeks of the world could actually put in a serious search. How did you want it? How did you want it to actually search? Just the summaries or just the links? But starting to look a lot more like what we're familiar with. And here's Google used. It's actually the Veronica database that I mentioned. And now Gopher has moved away from the menu into putting in a search term just to go into the index. So again, we're talking about a few 100,000 documents that people have purposefully put into a data set. Okay, I'm assuming you'll give me a chat if I go offline or something. So, so that's FTP. So along comes the internet. HTTP and URLs get brought into the play by Tim Berners-Lee. 1989 was the first sketch, which if you've got your computers open, you can actually see that first sketch. It's been scanned into the web somewhere. So here we have, again, it's a request response. I ask for something from my computer to yours. Your computer answers and says, sure. It all depends on working. It will only work through unique resource locators, so URLs. So I say, I want this document, but it's at this site. And so that site has to be unique, or there's no way it can automatically go. And my site has to be unique. And so, you know, one of the big contributions of the web and Tim Berners-Lee is this new HTTP, the Hypertext Transfer Protocol, to replace the notion of it's just a binary file. I'm just going to send it to you. But it didn't just actually come out as a brainwave in 1989. So Vannevar Bush was the U.S. President Science Advisor after World War II. Now, I wasn't there either. So anyway. And he came up with a lot of great ideas. And one of the things that really stuck is an imaginary machine he called Memex. And the idea, so here's a picture from Time magazine. And it's worth reading if you're interested in history at all. His idea was that everything that we talked about or we wrote on notes or we read in a book, it would all go into our kind of like a brain that was an exterior brain. And then there would be paths through it. So there would be kind of like hypertext links, only he called them trails and paths. And then when you wanted to go back, you could go back and follow these trails and paths through it. And here's his little sketch of it, which is somewhat amusing in hindsight. But you can see actually he's got some he has here, these are what paper documents, but if you look at it now, it looks like little tablets. So begins you think, oh, well, actually, we're not that far away from this. So this was in the library circle sort of a vision or a dream for years and years and years. And Ted Nelson, who's the researcher who actually invented the term hypertext in the 1960s. And so he also had a dream, and it was hypertext is a way to link and access information of various kinds, so that's really important, as a web of nodes in which the user can browse at will. Well, if you decompose that sentence, you're pretty close to the way we use the web now. We link to and get it, access information of various kinds, photos, Excel spreadsheets, blogs, scientific data, you know, all kinds of things. And we can browse around relatively at will. So we can follow links, we can navigate. We don't have to just search and go to one thing. So not too far off. Um, so here we have 1989, we have this HTTP. And the main thing to remember here is there's only really two protocols, a GET and a POST. So get me this data from your site, and your site saying send this data back to Carolyn. So it's a parallel protocol. And you're all computer scientists, so I know you know this. But so here's a request. Here's a GET. So I want to get this file, this HTML file, using this protocol from this URL. This URL, example.com, generates a response to me, which is a put. I don't know what happened to my put. Anyway, so there should be a put here. The put, according to this protocol, 200 is an error message saying we're good to go, no error, okay. Here's the date, here's the server kind, we're running Linux, last modified, electronic tag. Now it starts to tell me interesting things. This is a text HTML document coming to you. It could be a binary, it could be something else. Here's how long the file itself is, and now I'm telling you I'm done. Close. Okay, so it's just a little header. Now the FTP did not have headers of this kind, okay? So it's a big difference because you can read it, which is important. So here's a little hello world. So here we have the tags. You're all familiar with the tags. And what does this do? This actually does two things. One, it decomposes the file into nested. Whoops, sorry, you can't see my hand. Into nested, right? Little nested parts. So we have here's the beginning and end. And who's it talking to? It's actually talking to your browser, saying to the browser, wherever you put the title, go and put this text where that belongs. Put this text. So it's instructions to visualize how you display this document. So it's critically important in two ways. One, it actually starts to break up the message and say, we're going to help your browser show this. And second, it's actually readable. So, you didn't need to be a computer scientist to figure out what this was telling you, right? So if you received this file and you didn't know anything else about it except for it was text, you could actually write a program and figure out how to do something with it. Completely different than any files that had gone before. So this grew out of a body of work called SGML, General Markup Language. Must be, yeah, I don't know what the S is. You can look it up. So where do we go from there? So the HTML is all about telling the browser how to lay this thing out on your screen. XML is all about the semantics. So here's a little XML thing. And again, you can read this. No, it's not hard to read. Here's the question, here's the answer. So it's not saying how to lay it out. So clearly there has to be some mapping between the XML and the HTML for your browser to do it. But if you think it's a huge advantage of knowing semantics, you can actually write programs and apps that actually do something significant with this because you know where the question is and where the answer is in this case, and you know that this is a quiz. So you can actually start to write serious programs. I've got to talk faster. So how did all this work out? Here we are. The red line, the arrow, shows about the time of the introduction of the web, 1990-ish. And so over this is logarithmic. So over here, these are all the hosts, the servers, if you like. And so more and more and more and more. We all got excited about sending files to our friends. And then all of a sudden, this thing kind of goes nuts. If you look at it, it just goes crazy. Here we are, 2011, over 1 billion servers, right? So we went from 8 servers in 1969 to 1 billion, and most of the growth, if you look at it here, 1999, so 2000, it went from 100 million to 1 billion, right? So pretty steep growth. Okay, so this is part of a Cisco slide that I used on the bottom, but you can see here, it starts out by having the protocols, and then it moves up into the browser so we can see it. And there we are at 1995 at the end of the 90s. So that was really the work of that group. So then what happened next that I think is tremendously exciting is this idea of not just moving the data back and forth, but actually people actually starting to use it for work, right? So they're using the both sides, the server and the host, for work. So the e-commerce, web services, and the whole idea that everybody on the planet can start to make a website. Nobody thought of that when this started. I promise, nobody thought of that. So here we have Amazon. Um, Amazon.com started in 1994, and this is a very early screenshot, and that's why it's a little blurry. But it'll give you a sense it wasn't that far off what it is today. Right? So this is a great mix of e-commerce, and it was actually the very first successful e-commerce. But it's this transition that melded the bricks and mortar store with an electronic commerce, which is probably largely why it was so successful, because you could buy the book, but then the actual book arrived. So we're a long way from Kindle at this point. But they built a very successful, first really successful and hugely successful, and it's worth kind of thinking about the changes. And then we merged into what I would call people-to-people e-commerce. So eBay's and Kijiji. I don't know if you have Kijiji, but it's totally cool. People just post the stuff, and then other people go in and they look for it. So eBay is more of an auction, and Kijiji is more like the classified ads in your newspaper. It's tremendously, like hugely successful, at least in North America. Everybody I know, they put their apartments up in Kijiji, their cars. I bought a boat on Kijiji. It's just everybody is very social. It's just people putting their stuff on and then going and buying stuff through them. So a whole different way of thinking about it. But this only works, of course, if you can make payments. So I'm not even going to go anywhere near the whole trust issue. But PayPal and PayPal-like things were totally critical in making that shift so that we could actually do transactions on the web. So you can't run Amazon, you can't run anything that's a business on the web unless you've got something. And PayPal was really the first that figured out they could be the trusted intermediary. They could be the trusted broker in this. So all the buyer has to do is trust PayPal not to rip them off. And all the seller has to do is to trust PayPal that they will get paid. And so it's that, third-party trust. I'd be surprised if many of you don't have some access to PayPal. So how did this all work out? So here we have the green line is the Amazon bookstore sales, flatlined, right? Well, this goes up to 2009, but it's pretty flat line now. If you look at the red line, that's the online Amazon growth from 2003 to 2009. So all the area under the curve, the increase in books, essentially, bought online. People are still going to the stores. If you look at general retailing in the United States, you see that it's increasing, but nothing like this growth here. And if you think of Amazon or bookstores, so they have the benefit of this part of their sales. People still go to Chapters and Amazon, and they can buy it online. Big difference. Okay. So probably more important is people actually starting to move to what I would call a thin client. So actually using the web to hold the application itself, and more importantly, to hold the data. So even Amazon, you go to Amazon, you do your transaction, they remember everything there. You don't have to write down anything. You don't have to remember what books you bought or what you liked. They do it. So as we kind of move to the server part, actually providing resources, not just computational and application resources, but also storage resources to keep our stuff. So then you move into the whole kind of, I'll just use Google Docs as an example. So you can go to Google, you can use their spreadsheets, you can create presentations, you can do presentations with Prezi. You can actually do all of this, and it's stored there, which is a huge advantage because as people move around, they don't have to keep their equipment with them. They can move up. I can go to your college and get at my all my presentations that I've got or my Word files or whatever that I have in Google Apps. So that sort of free, it breaks the tie between me and my storage, which is great if you move around a lot and not good if you've got secret documents, I suppose. But by and large, we've all changed a lot of the way we work. So we can get away with much lighter weight, smaller storage devices that we move around. And it's the only way we're going to be able to use truly mobile devices like our phone. We don't have to store everything. And I won't even go into your apps and mobile apps. I just ask each one of you to think about how many apps you've got on your phone. Okay, and the number is bigger than 10. So anybody there who has fewer than 10 can tell me later. I don't think there'd be anyone. Okay, so here's a little, so where are we here? So this is 2008, which isn't that long ago, and 2013, January. App Store downloads. By January 1st this year, 40 billion. Now, not all on my machine, but I have a lot. But that is a lot. That's like, how many billion people are there? That's like 5 or 6 each. And not everybody has a phone. Okay. So the other part of this using applications is this notion of users, that's us, everybody on the planet becoming an author. So everybody contributing, not just the, the teachers and not just the business people, but every single kid, every single grandmother, every single person can get on there and they can write a blog, they can add tweets, and particularly they can actually make websites. So this was a big deal in the early 90s, 92, 93, when HTML kind of hit. All of a sudden, people were kind of liberated to say, I can do that too. It's not that hard, right? So it's really been this shift of authorship from the computer science, really knowledgeable, technology people, to everybody. And it's shifted it from only organizations to school kids to everybody. And there are billions of personal websites, right? Just billions. Okay, so that's where we are. So now we're in a spot where we've got pretty much everybody using it, everybody creating it, everybody contributing. And then sometime around in 2004, 2005, people started to say, well, this is a way that we can start to connect each other. We can build communities of users. So there were communities of users if you look at the old list servers. So there were these list servers where you could join up and then you could see everybody else's comments. And that way they built these little topic-centric communities. And it was sort of odd. They would have their own culture and their own rules of engagement. So there would some where people were actually kind of nasty to each other. If you made a mistake, somebody would, what they call flame. They would send and say, oh, you're not very smart. How could you have said that? Blah, blah, blah. But by and large, they grew into people sharing, so a very contributory kind of thing. And one of the first was Flickr, and I'll use Flickr as my example. And that moved us into what we would now all recognize as social media. So a little timeline though. 1971, people were sending email. So they went between these 7 or 8 or 10 networks, if you remember my slide from the very first section. But if you were in one of those networks, ARPA or the universities in Canada, you could actually send email between the universities in Canada. You could send email if you knew the person. 97, we start to get chat, serious chat and blogging. So blogging, this idea that I'll just talk. I don't care who listens. Just kind of like today. I'm just assuming you can hear. And then you move into the kind of MySpace and Friendster, and where you're starting to get teenagers and kids actually looking at it differently. It's not just text. It's starting to be sort of more imaginary world and kind of defining in different ways what my community looks like. 2004, we start to get into this, to the Facebook, Flickr, where we're actually going there to share. We're not exactly concerned about who's reading it, but we're starting to share our thinking. 2006, Twitter starts, which are really just tiny blogs. Most used communication on the planet. And so where were we in 2011? This was the last time I could get data. There were 550 million people on Facebook, 65 million tweets a day, not all from me, 2 billion video views in a day through YouTube. And I do know that this past year, 2013, there were more photos taken and shared on the web than photos were taken in the whole history of time. Right? So that's a lot of photos. So you think about the last time you took a photo, it was probably 20 minutes ago. So let me just talk a little bit about Flickr here. So this is just a picture. So what happened was people, you would set up an account. This is not my account. You set up an account and then you get all your relatives to say, go to this account. And it was easier. Everybody could put up their pictures of kids up there. And then people started saying, well, I don't want to just share it with my friends. I'll just make them publicly available, like the ones that you see here. And then people would start tagging them. They would say, for example, Blue Nose, Ship, Nova Scotia. They would say, quaint church, Nova Scotia. And here's a odd sign in Nova Scotia. I don't know why it's odd. Here's the valley in Nova Scotia Road. And then ultimately what happens is that people use enough similar words that you could go in and search for photos for Nova Scotia, which is what I did. You can see up here. And these were some of the pictures that showed up. None of the picture takers were the same. There were completely different, in this case, 6 set of people took these pictures. They independently put their little tags on. But when I put in my search, this is what I came up with. And often you see it in terms of community word clouds, but these are based on folksonomies. So folksonomies are taxonomies of all those tag words put in typically in alphabetical way, and you're familiar with this. So in this particular set, the most popular were family or wedding. Vancouver hardly ever showed up. York showed up maybe once. I'm surprised Ocean didn't show up more, but it didn't. And so you can get a sense. And if you clicked on it, it would go and show you, it would do a word search, if you like, and show you those photos. And so it was a whole new way of defining. And it actually worked tremendously well, considering that nobody did it intentionally. And so we have this huge evolution, and you're familiar with all of these. So moving from a Facebook in many ways is a sequence of inputs. I put up something, you put up something, I put up something, somebody else puts up something. MySpace is more of an imaginary world where we built this world. I call it a world of intent. And you say, well, here's my role, here's your role. Twitter is actually a tiny little sequence of micro posts or blogs. But again, it's a sequence. I put it up, somebody else puts it up, and we get this time ordered. There's no, I don't know why Twitter doesn't allow us to recluster the whole thing so that we can do it actually more by topic or by who sent it, or, you know, it tends to be strictly sequential. And then all of these new Instagram, etc., for photo and video sharing. And as I said, more popular, starting to be more popular than tweets. So here, explosive growth. So you can just look at this. So 2008, 2012. One thing you need to notice is the time frames we're looking at are getting shorter. This is only a 4-year time snap. So we've gone from video viewership, 13 billion to 43 billion. There wasn't a single tablet on the planet that was listed, and now we have 55 million. Tweets per day, 140 million. I hate to think my 2 little tweets are adding to that, but there you go. Twitter accounts, 300 million. Facebook accounts. Okay, so the numbers bigger than I can actually comprehend. But that to me is a compelling picture of a web of people people are connecting with each other in a very personal and informal way, right? And with no particular purpose most of the time. I'm just sharing. I'm saying, here's something I thought of. You may find it interesting or not. It's up to you. So this is an interesting picture that came from Mark Schuler last year. And he calls it read-only web, read write web. And this is what I call my second phase. We're actually doing applications and we're actually starting to be authors, social web. So I'd like to talk a little bit, what's out here? What comes after this? Okay, so here's my other student at Cisco. So you can see this is the 2002-2011. Again, we're mostly browsers, and all of a sudden, 2008, the internet goes nuts, right? Look at this line right here. These are all, as the social stuff came on, this is the huge change from 2008 to 2012. So look at that activity. It's kind of interesting. Okay, so lastly, I wanted to talk very briefly about the Internet of Things. And so this is really the idea that if we can actually collect data from everything. The question is, what are we going to do about it? So this is a little Dutch company called Spark, and they put a sensor on each of their cows, and it transmits 200 megabytes of data for each cow each year, so a little bit every day, so like 75 megabytes a day. It tells their temperature, it tells where they are in the field, how much they've eaten, et cetera, et cetera. And then the farmer, if you can imagine, spends a lot of time looking at his screen, and he's got software that says, oh, cow 4 in field 2, we better go and do something. Big startup. Okay, so here's just a little example. So things I want you to look at are things like the biosensors, microcontrollers, sensors for pollution, visualization, data stream coming in, and virtual environments. These are big, big data streams. Right? So the data streams coming from weather satellite, from the oceans, from the from television and telephones is huge. So as you go along, what did you need to do first? So it's this RFID tags, right? So as we move from barcodes into RFID tags, these were direct connections to the computer. And once they're digital in this way, they're on the internet. And so people use them in the supply chain. So I need this part tomorrow for my car, go find one and send it to me. And then a lot of surveillance, healthcare, food safety. And now we're moving into locating people and objects. Where is my correlated thing? Where is my sun? Where is my car? And then we're going up here, 2020. So we're kind of down in here. We're starting to have cars where you talk to the car and it calls up, tells you that there's lights blinking and you need gas or whatever, and then it tells you where the nearest gas station is, and etc. So that's where we're going. Okay, so what do we need to get there? We need this interesting combination of sensors. So we need sensors, lots and lots of sensors. We need an internet that will actually be slightly lighter weight so that we can send this sensor data without so much packet data around it. Right? So you don't want to be sending 100 bits of data with 100 bits of packet data. Right? So you need to be able to do this faster. And RFIDs, because RFIDs will actually store data and can do some computational things. So it's this combination that makes this possible, and unique identifiers. So your refrigerator, your microwave, your chair at home, everything needs to have an absolutely unique identifier, or we can't. So the guy with the cows, every cow has to have a unique identifier, or the thing doesn't work. Right? So that's actually a problem going forward, because we're not talking about 100 billion things. We're probably talking about a billion things. So if you're interested in this, the guru in this is Kevin Ashton at MIT, and what he says, which I think is interesting. We have, say, roughly 50 petabytes of data on the internet now. They were actually put in by people. We've connected it. But people aren't very good at things like cows and cars and microwaves. So we're at a spot where the computers are going to start generating their own data. So organizing it, moving it around, allowing access to it by computers and by people, and doing data analytics on it will certainly be the next wave of internet activities. And so you can see here, we have, I don't know that you can actually see it. So here we go. We look at 1975 to 2000. We've got, say, a billion. So we're rough. So we've got, say, a billion servers, 5 billion people on the web. We've got 50 billion things that could be hooked up. And we don't have 50 billion things. And that's a pretty small subset. That's just devices. That's not sensors on things. That's not a sensor on your watch. That's not a sensor on your pen or your purse or anything. So you can imagine the scale up issue that's going on. So let me just conclude here. So what's happened here? I divided it neatly into 4 sections, but of course it wasn't this neat. It was messy and it's overlapping, and some things are going on and some I haven't even mentioned. But we do have a move to massive, massive connectivity. We have had a total shift in who owns the data in the web. We all now contribute. A total shift in ownership. So if you think back at a library, what would happen to the library if we all took in our notes and journals and said, here, you look after it? So that's not part of the library model, but that is part of the internet model. We've moved to more and more processing done on somebody else's machine. They're looking after the data. I just go to Google. I just do my thing. I go to Prezi. I do a presentation. I leave it there. Get it on the web wherever I am. So I've divorced myself in many ways from a dependency on a particular machine. This notion of personal social connections through media like electronic bits is totally fascinating. So we do it. We all accommodate it. We don't think too much about it. But it does change the culture in many ways. I'm not one to say whether they're all good or bad, but I do think we have to recognize that our kids growing up are actually engaged in different social connectivity than any of us were, I suspect, unless there's somebody there younger than 12. Sensor connections, this idea that there's a world that we don't really connect with, but my stapler and my coffee cup are talking to each other. That sensor connectivity and how we control that as societies is probably an interesting thing. There are some huge challenges. There is too much data. What data do we trust? What data is useful data? Who put that data on there? If everybody's putting on data, how do I know what's good data? Privacy is more and more of a problem. Do I, 20 years down the line, do I really want people to know what I thought about somebody in 2013? Maybe, maybe not. So we need to build different norms around how we share information. And there is this, I think, some sense of personal autonomy, and that's around people taking some ownership and some responsibility and accountability for what they share on the web and how they use data that they find on the web. So there will also be cultural differences and cultural norms will have to be established for the way that we live in a different kind of world. So I'm going to leave it over to you, but I thought I would leave you with something to think about. So here we are, 2013. So many of you will still be here in 50 years. So just try and imagine, if things are going faster and faster, what this would all look like 50 years out. So my guess is, I'll just put mine on the table, that 50 years out, we won't have this conversation because this will be about as exciting as talking about how the telephone works. So I'm going to leave it over to you. I'm going to go back one and I'll leave it there. So if there are questions, I'm not exactly sure how this part works. Are we ready?